Welcome to week 24 of Statistics 1 Maintenance. Once again, doing exam questions, practicing, getting ready for our externals coming up. Hopefully these questions are helping you get a bit more used to the kinds of things that are going to be asked in an external and giving you good practice at figuring stuff out. The first question today is a coded data question. We've got some information here. We've got n values of the variable x, and we know that the sum of x minus 100 is equal to 216, and we know that the sum of x is equal to 2416. We've got to find the value of n. Alright, so what this actually means, let's take this first one for example here. The sum of x, and then since there's n lots of data, take away 100n should be equal to 216. That's one of our pieces of information. Now we happen to know that the sum of x is equal to 2416. So 2416 minus 100n is equal to 216. We just do a little bit of rearranging here, and we get n is equal to 22. So just a review, this bit here can be rewritten as this bit here. Right, the reason for that is the sum of x minus 100 for n values of data is we take each value of x, and then for each of them we take away 100. So we're taking away 100 n times. So we could just add all of the x values together, which is sum of x, which we know from over here, and then take away 100 lots of n. Okay, so that's how I got that. Now moving on, discrete random variables. Fair spinner has edges numbered 1, 2, 3, 3. Fair spinner B has edges numbered minus 3, minus 2, minus 1, 1. Each spinner is spun. The number on the edge of the spinner that comes to rest is noted. Let x be the sum of the numbers for the two spinners. So we're adding them together. So we can just add our values in: minus 1, 0, 2. The next one at the top here is 2 minus 3, so negative 1. You can see these ones are 0, 0, because 3 minus 3. This is a 0. This is a positive 1. 2 and 1 is 3. This is a 2. This is a 4. This is also a 4. A 2 and a 1. So we've calculated the possible values there. Draw up a table showing the probability distribution of x. So what are the different values that we can have? Well, the lowest one seems to be minus 2. Then we have minus 1. We have 0. We have 1. We have 2. We have 3. And we have 4. Those are the different values. And now we've got to look at the different probabilities of each of these. So negative 2, there seems to be one value out of 16. Negative 1, it looks to me to be two values out of 16. So 2/16. 0, looks to me to be 4 values out of 16. Positive 1, we got 3 values out of 16. 2, I think also 3 values out of 16. There's 1 3, so 1/16. And there are 2 4s, so 2/16. Now, theoretically, they should all add up to 16. So 2, 3, 6, 9, 13, 15, 16. Perfect. Now, to find their x, we actually first need to find ex. So I'm going to find ex here, and that's just going to be minus 2 times 1/16 plus minus 1 times 2/16 plus 0 times 4/16 plus 1 times 3/16 plus 2 times 3/16 plus 3. Wake up, brain. 3 times, that's the vacuum cleaner, 1/16 plus 4 times 2/16, and then we add that all together, and that will give us 1. I think it gives us 1. Now to find varx, remember varx is going to be, we're going to take this away at the end, take away 1 squared at the end. So it's kind of like, we're going to go minus 2, so we take this value here, we square it, then we times it by its probability, and we do that the same all the way along. Squared times 2/16, and then we're going to take away 1 squared. So that's how we work out varx, and this gives us 23 over 8. Find the probability that x is even given that it's positive. Okay, so this is the probability that it's even intersection with positive over the probability that it's positive. Now this is equal to now probability even and positive. So even and positive, we can look at those. So that's even and positive, and that's even and positive. So that to me is 5/16. So I'll pop that on top. 5/16, and then on the bottom the probability that it's positive. So you're looking at all of this stuff here. So 3, 6, 9 should be 9/16, and so that obviously simplifies to 5/9. Alright, moving on to probability. We should turn the vacuum cleaner off, it's rather annoying. Sorry about that, guys. 1 plastic robot is given away free inside each packet of a certain brand of biscuits. There are 4 colours of plastic rabbit: red, yellow, blue and green, and each colour is equally likely to occur. Nick buys some packets of these biscuits. Find the probability that he gets a green robot on his first packet. Well, obviously it's 1/4 if they're all equally likely. What's the probability he gets a first green robot on opening his 5th packet? So that means he doesn't get a green robot 4 times in a row, and then he gets a green robot. So 3/4 is the chance of not getting a green robot. We do that to the power of 4 because he doesn't get it for 4 goes, and then on the 5th go he gets it. So this happens to be 81 over 1024. Next friend Amos is also collecting robots. Find the probability that the first 4 packets Amos opens all different coloured robots. Okay, so it doesn't matter. The first one, it doesn't matter what he gets. So this is 1. Then the second one, there are 3 options that will give him a new coloured robot, and 1 option out of the 4 that would give him the same that he's already got. Now, once we open the 3rd packet, there are now only 2 options that will give him a new colour that he doesn't already have. And then finally, with the 4th one, there's only 1 option that he will that could be different from the others that he already has. So this ends up being 3/32ths or 3/32. I don't know how you say that. All right, 3/32. Now the next one is a permutations combinations question. We've got 8 friends. Travels to the airport in 2 taxis. We've got P and Q. Each taxi can take 4 passengers. The 8 friends divide themselves into 2 groups of 4. 1 group in taxi P, 1 group blah blah blah. Okay, with John and Sarah traveling in the same taxi. Maybe they're keen on each other, I don't know. Find the number of different ways in which this can be done. Okay, so John and Sarah have to be together. Okay, so we could think of it this way. We could talk about taxi P, and we've got John and Sarah, and then there's 2 more, and then we've got taxi Q, and we've got, so this is one way of doing it, 4 seats. So we go in taxi P, we've got 6 other people apart from John and Sarah. We can choose 2 of them for taxi P, and then we just gonna go 4 choose 4 the leftovers are going to be in taxi Q. So it's just saying how many different ways it can be done. We're not talking about arrangements within the taxi at this point. Now, of course, we could actually have P like this, and then Q we could have JS, and then like this. So you can see that we could just times this by 2, and that should give us the number of ways that we can do this, and that ends up being 30 ways. Now, each taxi can take one passenger in the front, and so this picture now belongs to the next part of the question. Each taxi can take one passenger in the front and 3 passengers in the back. See the diagram. Mark sits in the front of taxi P. Okay, good old Mark. And John and Sarah sit in the back of taxi P next to each other. Yeah, see, they're going out, right? They can't bear to be apart. J and S. Okay, that's one way of doing it, right? Find the number of different seating arrangements that are now possible for the 8 friends. Okay, so Mark's there, and then these guys are in the back. Now, thinking about the back, we've got to choose another one of the friends. So there's 5 friends left, right? Because there's 8 altogether, we've taken up 3. So 5, choose 1. So there's 5 different options that could go into this taxi P. And then, once they're in the taxi P, how many different ways can we seat them? What have we got there? I think times 2, right? So we could have John and Sarah. Let's just delete this out. We could have John and Sarah in these ones, which would mean the other Larry is there. So that's one way, right? Or we could have John and Sarah here, which means the other Larry is here. Okay, so that's one way of doing it. 2 ways. But then also don't forget that John and Sarah could be switched around, right? So John and Sarah could be this way, or they could be this way. So we're going to times that by 2 again. Okay, so that's the possibilities for taxi P. Now, what about taxi Q? Well, the leftover 4 people, there's going to be 4p4 ways of arranging them in the taxi. Or 4 factorial, right? 4p4 or 4 factorial. And this is going to give us 480 ways of arranging everybody. Okay, our favourite discrete random variables, binomial distribution. The probability that a lighter fails is 0.05. A pack of 15 is bought. Find the probability that more than 2 lighters fail. Okay, so what we're going to do is we're going to go 1, take away the probability that 0 or 1 or 2, or maybe I should say and. We actually want all of them lighters fail. So that's what we're going to do. Now here's what we do. 1, take away. We're going to go 15, choose 0. This is for 0 lighters failing, times 0.5 chance of failure and to the power of 0, because none of them fail, times 0.95, which is the chance of not failing, and that will be to the power of 15. So that's the 0 one done. Then what about 1 lighter failing? There's 15 choose 1 options there, so 15, times the chance of failure, which is 0.05, so that's to the power of 1, and then times 0.95, so the other 14 don't fail, and then we should have a bracket there. 15 choose 2 lighters failing, times 0.05 to the power of 2, times 0.95 to the power of 13, and then we just chuck this into the old calc, and when I did this earlier I get 0.0362 to 3 significant figures. Now moving on to normal distribution. Don't forget, remember we have our formula here. Our z number is for the standard normal distribution is x take away mu over the sigma. Now remember, this is your mean. This is your standard deviation. Okay, So let's read the question. We've got a petrol station finds that daily sales and litres are normally distributed with a mean of 4250, so this is this one, and a standard deviation of 560, so this is this one, and find on how many days of the year the daily sales can be expected to exceed 3,900 litres. So what I'm thinking here, team, is that this here is going to be our X value. So there we go, we've got all of those. So let's do it. Exceed, we want to exceed this, so we're going to go 3,900, take away the 4520 over the standard deviation, which is, what the heck is that, 560, and this will give us a Z number. Now what you'll find is we're going to get a negative Z number when we do this. So we're going to get negative 1.107. Now at this point I will probably just sketch for you what's going on. So here's our, oh my goody aunt. Okay, here's our standard normal distribution. This is our mean. And we know that the mean is higher than the X value that we started with here of 3,900. So 3,900 is over here. And we want the probability that exceeds this, that it exceeds this, okay? So the problem with your Z table, of course, is that all of your values are positive Z values. So what we do, this is Z negative 1.107. So what we are going to do is we're going to go to positive 1.107, which is here. And because of symmetry, that value on our Z table will tell us that this the probability of this brown bit, which is exactly the same as the probability of the pink bit. Okay, so we're going to go to our table. We're going to go to 1.1. Here's 1.10, and then we're going to add to it. Now, what does it say? 7. So this one here. So we're going to go this bit. 0.8643. So here it is. Probability that X is greater than negative 1.107, and we say equals phi 1.107. So to get phi 1.107, we've just looked it up on the table, equals 0.8643 plus 0.0014. So you put 2 decimal places before that, 0.0014, and that gives us a value of 0.8657. Now we're just about there. We want to know on how many days of the year can daily sales be expected to exceed that many litres. So last step in the problem is 0.8657 multiplied by 365. And that will tell you approximately how many days. Now when I do this, I'm getting 316 days is my end result. And that's the correct answer. So, hope this has been helpful to you. Please let me know if you aren't understanding any of the explanations. We can talk about it in class, or I can explain it more thoroughly in an email or another video. Alright team, God bless. See you later.